Okay, so one other thing that we often get you guys to do, and most trade schools get you to do, is to take a look at the three-phase dual voltage motor. And then instead of having this, where we have all of the terminals coming out and clearly marked, as on this trainer, you have all of your terminals and they're not marked whatsoever. So you have 9 leads coming out of the motor, and you have absolutely no idea which one is T1, T2, T3, all the way to T9. And there's got to be a way that we can determine which is which. And the only way to do that would be similar to the buck boost test that we did on the transformers. This is a rotating transformer, so we should be able to figure this out by putting an AC voltage to it and looking at voltages either summing together, being an additive connection, or doing the subtractive connection.
Okay, so first thing we need to do here is we need to look at our ohmic value of each of our terminals to determine whether we have a delta wound motor or a Y wound motor. And we did that in the previous video. When we looked at 1 and 4, we found continuity, and we found that that was a value of 11 ohms. Then we also found that there was continuity between 2 and 5, and that was the identical resistance value, which makes sense because it's the same ohmic value, right? Same gauge of wire and same number of turns. They're the exact same winding, so they should see the exact same resistance value. So we found 11 ohms between 1 and 4, 2 and 5, 3 and 6, and then we found no continuity between any of these terminals and any of the remaining terminals, right? They were standing alone with just 2 terminals that had continuity. Okay, then we took a look at these guys, and we don't know which one's 7, 8, or 9 at this point. But between these 3 points, we found that between any 2, there was 22 ohms, which makes sense because that's double this value, right? And if you look between this point right here and this point right here, we're looking at the value between 2 windings from 7 to 8. That would mean that the ohmic value would add 11 ohms and 11 ohms to give us 22, right? So remember, these guys here, these guys here are each 11 ohms, summing to give us 22. Okay, so there's 22 between 7 and 8. There is 22 between 8 and 9. And what follows is that between 7 and 9, we're going to find that resistance value of 22 ohms again. Equal resistance values all the way through. Now, as soon as we found this, where we had 2 terminals and they didn't have continuity with anything else on the motor, then we knew for sure that we had a Y connected motor. Because if we look at the delta and we quickly draw out the dual voltage delta here, you can see that on any of the outside points, you would have continuity between 3 different terminals. 1, 2, 3. 1, 2, 3, and 1, 2, 3. Right? So you would have 3 separate connections, right? Where you had continuity between 3 different terminals in this delta motor. We don't have that over here. We only have this where it has 3 different terminals in one spot. The remaining terminals only have continuity between 2 points. And at that point, we know for sure that we have a Y-connected motor. So our next step now is that we don't necessarily know each of these terminals, right? So we're just going to arbitrarily label this Y connection 7, 8, and 9, because we have no idea which one is which yet. So we're just arbitrarily labeling those guys. And from here, we're now going to do the buck boost test with our external connections out here, and we're going to see how the magnetic fields add and subtract when we provide power to this Y connection and then make an autotransformer connection with these guys, and we'll see how the magnetic fields interact with each other. Then we'll see which one is 1, which one is 4, which one is 2, which one is 5, which one is 3, and which one is 6. So it's very cool. Magnetically, you can determine which windings are there, and then again, magnetically, we can determine the polarity of those windings in that we'll be able to find out which one is the 1 and 4 pair, and then we'll be left saying, all right, which one is 4 and which one is 1? Again, we'll do the buck boost test to determine with authority which one is 1 and which one is 4.
All right, guys. So we've got to do the ohmic value on each of these windings here. So let's take a look at these guys right here and see if we have continuity. Beauty. So we got continuity between 2 points right there. Let's see if we've got continuity on anything else. So nothing else has continuity. We know that the answer is going to be continuity on number 9, but let's just keep going and see. So no continuity, but we do have continuity here between these 2 points at 22 ohms and between these guys and again at 22 ohms. So at that point, we've got 3 terminals where we've got continuity. And at that point, we have no idea whether we have a delta or a Y because we got 3 terminals where we have continuity. So let's see on these guys above whether we have continuity between 2 or 3. So on this guy, we know that we're going to have continuity between 4 and 1. And you can see there that it's half of the value that we saw on these guys, right? Let's go back between 7 and 8. On the Y connection here, between those 3 terminals, we saw, let's not be making very good connection there. There we go, 22 ohms, right? Between these guys, we've got half that value at 11 ohms. Okay, so this is one winding between T1 and T4. At this point, let's just double check and see whether we have continuity anywhere. We know we're not going to because that value was half of what we saw on 7, 8, and 9, right? So that's just one winding there. Beauty. So that's one winding at 11 ohms. The reason why this is double the value between 7 and 8 is because we're reading across 2 of those windings, right? 11 plus 11 giving us 22. Okay? At this point, when we see 3 terminals with continuity and then just 2 terminals with continuity, we know we have a Y-connected motor. This is our Y connection here between 2 windings, 2 windings, and 2 windings. And over here, this is a single winding between what we think is T1 and T4. But we have no idea what those are yet, right? T2 and T5 have the same ohmic value. T2 has no continuity between itself and any other terminal other than T5. And again, it's the same as what we saw in T1 and T4. Let's take a look at T3 and T6 because those are the 2 remaining terminals. And again, whoa, that's not making good contact. Hang on. Still not making good contact. There we go, 11 ohms. Okay, so the same value all the way through. 11 ohms, 11 ohms, and 11 ohms. Okay, this guy right here has no continuity with anything else other than with T6. Okay, so here we can see, easy now, we can see 1 winding, 2 windings, 3 windings, and a center connection between these guys. Excellent. So at this point, we know that it's a Y-connected motor. All of the labels are here on this terminal box, but we're going with the thought that the labels are not there, and we've seen that there are windings there, but we have no idea what the actual terminals are. So the next thing we need to do is the buck boost test to determine where each of the windings are, and then we'll do a connection between these guys, and we'll see whether one is T1 and the other one is T4. So we're going to magnetically see by putting voltage to these terminals and connecting them up with this as an autotransformer to determine which terminal is which on each of those windings.
Okay, now the following method is different from the Delmar textbook and the AC motor controls textbook. In those textbooks, they provide 3-phase to 7, 8, and 9. We're going to try a different way. I haven't tried before, but it seems to be working out. So what we're going to do is we're going to take a 120 volt source, which is readily available in any of our shops there. So we got 120 volts, and we're going to put that to what we think is terminal 7 and terminal 9. So we're going to juice up that portion of the winding with 120 volts. What's cool is that the other windings are wound right on top of there, right? So 1 and 4 and 3 and 6, those 2 windings are wound right on top of 7 and 9. So when we juice this up, it's going to have some transformer action, and this changing magnetic field here is going to induce a voltage onto this guy and this guy. What is cool is that when we put voltage to 7 and 9, it will not induce a voltage onto this winding right here between 2 and 5. So over here on 1 and 4, we're going to see a voltage develop right here. So in our particular motors, you're going to find roughly 10 volts induced on this winding right here, and around 10 volts induced on this guy right here. And that is simply because those guys are wound right on top of these windings. Over here, between 2 and 5, you're going to see no voltage induced whatsoever. No voltage meaning like you're going to see like 1.25 volts induced there. Okay, so again, what the first step is you're going to arbitrarily label this guy 7, this guy 9. We're then going to juice it up with 120 volts. And the two windings that we see 10 volts on are going to be 1 and 4 and 3 and 6. We're going to keep going. We're going to put the voltage over here on 7, 8, and then 8 and 9 as well. And we'll see which windings get that induced voltage.
Okay, so let's start off by putting voltage to terminals 7 and 9. So let me juice this up here. And we'll take a meter reading of the voltage that's going into that Y connection there. And today the voltage is 118, 119. Let me just focus in on the meter here. So we got 119 volts going into 7 and 9. And we'll find that on 3 and 6, we should have a voltage being induced. So over here we'll have a voltage. There we go. So there's roughly 10 volts that's being induced there. On 1 and 4, we should see that same voltage. So roughly 10 volts being induced. And on 2 and 5, we'll see basically nothing. Okay, so you can see there that by juicing up 7 and 9, we have an induced voltage. So again, 118 volts here, or 119 volts, inducing a voltage on 1 and 4, and 3 and 6, because they're wound on top of those windings, and we're seeing nothing on 2 and 5, or virtually nothing, 1.27 volts there, right? Okay, so now we can see that this is what we think is 1 and 4, and this is 3 and 6, but we're not sure, again, which ones are which, because they have the exact same voltage induced, but we're getting closer to knowing the proper labels on each of the windings. Okay, let's turn that off now. There we go. And in my notes here, the last one the second one that we were doing was we put voltage to 8 and 9, right? So let's do that. Let's juice that bad boy up. Okay, so we've got, again, the same voltage coming in on 8 and 9. And let's see, we should have an induced voltage on 2 and 5. There's that same 9 or 10 volts on 2 and 5. We should see an induced voltage on 3 and 6. Let me just move the meter lead out of the way. Okay, so we got 10 volts there on 3 and 6. But on 1 and 4, we should see minimal voltage. There we go, so 1.6 volts. Okay, so on terminals 8 and 9, with 118, 119 volts applied from Hydra, we are seeing an induced voltage on 3 and 6, 2 and 5, and nothing on 1 and 4. There we go. So now with this, we can say that, all right, with authority, we know that this guy's maybe 2 and 5, this guy's maybe 3 and 6, or vice versa. But we know which one is 1 and 4 for sure now, because we're putting voltage to what we've labeled 8 and 9, and we're not seeing any voltage on what we arbitrarily labeled 1 and 4. Okay, we got one more connection there. The third connection we had was, what did we have? We got bringing voltage into 7 and 8. Okay, again, I'm turning off my power every time that I'm moving my 120 over. Okay, let's juice that up now. So again, same voltage coming into 7 and 8. And the windings that are wound on top of there would be 1 and 4. Beautiful, so there's that 9 or 10 volts. 2 and 5 should also see 9 or 10 volts. There we go. And with this connection here, we can, with authority, say which one is the winding with 3 and 6, because there at 3 and 6, we're seeing nothing. Okay, one more time. 118 volts applied to 7 and 8. The main thing here is we're looking for 3 and 6. We know that 3 and 6 are not going to have any voltage. But again, it's reinforcing the fact that we have 1 and 4 here. We have 2 and 5 here, with both with induced voltages. And now we can see with authority that these guys right here are 3 and 6. Excellent. We're going to have to keep going, though, because we're not sure which one's 3 and which one is 6. So we're going to have to do the additive and subtractive polarities next.
Okay, so what we did was we put 120 volts, and it wasn't 120 volts, it was 118 volts that day. And that source voltage was applied to 7 and 9. That induced a voltage of around 10 volts over here on 3 and 6, but we need to see how those two voltages interact with each other. So what we're going to do is we're going to put a jumper between 6 and 9, and we're going to create an auto transformer in between these windings and this winding over here. Okay, and then we're going to see the induced voltages that occur, or how those voltages are going to interact. So we're going to put our meter lead right here, and we're going to put our meter lead right here, and we're going to look at the voltage that develops between those 2 points. And we're going to see whether it's additive or subtractive. Right now, we said that over here, this voltage that was induced was around 10 volts induced on 3 and 6 when that 118 volts is applied to 7 and 9, right? Remember, there was an induced voltage here and no induced voltage over here. So this whole test now is to see which one is 3 and which one is 6. If we take a look at the magnetic fields that are setting up in this circuit here, we have these magnetic fields setting up like this. And so if this is in fact number 3, then this 118 volts is going to sum with the 10 volts, right? So the 118 volts and the 10 volts are going to sum to give us 128 volts. So if this terminal is number 3, then we're going to see 128 volts. Okay, then once we've taken that reading, what we're going to do is we're going to change the jumper. So we'll pause here for 2 seconds. You can take a look at this diagram for a couple of seconds and try and figure this out. This 118 volts is going to sum with the 10 volts, and we're going to get 128 volts. If that's what we see, then that's going to be terminal number 3. Okay, then we're going to take the jumper, and we're going to move the jumper over. And that jumper is going to go from 9 to 3. And then we're going to take a voltage reading right here. So we're going to move our meter lead over to number 6. So again, we've changed the jumper here. We've changed the placement of our meter lead. And then we're going to see the voltage that becomes apparent between these 2 points. Well, you can see that we're going with the arrow and then against the arrow here. So that's going to be our subtractive voltage. So we'll call this our additive voltage. And the subtractive voltage is obviously going to be the 118 volts that's impressed across 7 and 9 minus the 10 volts that's induced on 3 and 6. And then we're going to see roughly 108 volts. And when we see 108 volts on that terminal, then we can say with authority that that guy is terminal number 6. So it's a way that we can determine which terminal is which. We know that this is 3 and 6, but we have no idea whether this terminal is 3 and this terminal is 6. So we're setting up an auto transformer, and we're seeing how these magnetic fields interact with each other. If it's the additive connection, then we're going to label it as number 3. If we see the subtractive voltage, then we're going to label it as number 6. And now with authority, we can say that this guy is number 3 and this guy is number 6.
Okay, so let's take a look at this now. We've got voltage going into 7 and 9 based on the diagram that we just went over. We've got a jumper between 6 and 9, right? So we've jumpered that one winding in with the Y now. And we're going to see whether we have the additive voltage or the subtractive voltage. We got to determine whether we're connected up into 3 or 6. So again, if I'm looking right here on these guys right here, let me turn on the circuit. There's my 118 volts going into the motor there. Okay. And now that I have that jumper, if I go between 3 and 7, I should find that I have the additive voltage, which we said was going to be around 128 volts. Well, 126 volts. Looks good. So now with authority, we can say that that is number 3. If we change the jumper, right? So if we move that jumper from 6 over to 3, then we should see the subtractive voltage. So let me see if I can do that. These are safe connect terminals, so I'm just going to move this over, not touching any form of voltage there. And now I'm going to take a voltage reading between 7 and the other terminal, which is 6. Let me move this out of the way. And there's that subtractive voltage, right? Remember we said that for the subtractive we would get 108 volts? Well, we got 109 volts here for the subtractive voltage. So now we can say with authority that that terminal for sure is 6, right? If we move the jumper over here, then we would get the additive polarity, right? We would know that on 3 we should see somewhere around 128 volts. And there it is right there, right? A little shy of that, but we got 125 volts. Beautiful. Let's do the same thing for each of the different windings, and we'll do like this buck boost test on everything, just to make sure that we got all the labels on each of our terminals correct.
Okay, so following through, the next thing we're going to do is we're going to put the applied voltage to 8 and 9, and we're saying 120 volts, but we saw that it was 118 volts. Let me just clean that up for 2 seconds. Okay, so we're going to put 118 volts to 8 and 9, and then we're going to put a jumper between 5 and 8. And we're going to see how that induced voltage, that applied voltage, and this induced voltage of 10 volts affect each other. Okay, so then we're going to look at our voltage with our voltmeter, and we're going to look between this point right here and this guy right here. And we're going to put our voltmeter right there to see how those induced voltages affect each other. If we look at our magnetic fields that are setting up, then we've got current going from line 1 to neutral, and then we've got our induced voltage that's going to be happening as well. So if we have the additive voltage, where we have the 118 volts and the 10 volts adding together, then with authority we can say that this terminal right here is terminal number 2. Okay, so one more time, we put 118 volts to terminals 8 and 9. We put a jumper between 5 and 8, and then we put our voltmeter leads between this point right here and this point right here, and we're seeing the sum of all of those voltages at 128 volts. At that point, we can say with authority that this is terminal number 2. Okay, going back again, remember that this voltage right here induced 10 volts here and 10 volts here, and no voltage over here. At this point, we now want to determine which one is 2 and which one is 5, so we've created an auto transformer to see which one is 2 and which one is 5. In order to determine which one is 5, we're going to change our jumper here. Oops, just erase my blue there. Let's put that, come on. So this guy is still there. Our jumper is now going from 8 over to 2, and then we're going to move our meter lead over there. So our meter lead is now going to go to terminal number 5. Okay, at that point, we'll find that the 118 volts, if we follow this circuit, we're going with the arrow, but then against the arrow. So this will be the subtractive voltage. And at that point, we should see something roughly 108 volts between terminal 9 and terminal 5. And at that point, we can say with authority that that guy is terminal number 5. So again, we're creating an auto transformer. We're seeing the subtractive voltage there. And when we see the subtractive, we know that this magnetic field is going in the opposite direction of these guys. And so with authority, we can say that that is terminal number 5.
Okay, so next test we've got the jumper between 8 and 9 to provide us with our 120. We've got the jumper from 5 to 8, right? So we've jumpered those guys together. We're providing power to 8 and 9. And then we're going to take a voltmeter reading between 2 and 9 to see our additive or subtractive voltage. So let's turn it on. Okay, and we're going to go between 2 and 9. So there's 9 there, there's 2, and we should see, there we go. There's our additive voltage. Now again, the voltage is a little bit lower because remember there was higher induced voltages in some of the windings and less in others. So there's our additive voltage. If I take that same jumper and go to 2 and backfeed that one winding, then we should find that we get the subtractive voltage between 5 and 9. There we go. So there's that subtractive voltage there between 5 and 9. Beautiful. So now we've got with authority the proper labeling of terminal 2 and terminal 5 on the motor now. Beautiful. Okay, one more test, guys.
Okay, last one, guys. We're going to put the 118 volts. Again, it's not 120 volts today. It's 118, so we're going to put that 118 volts as our supply voltage to terminals 7 and 8. And then we know that that is going to induce a voltage on 1 and 4 and 2 and 5 and will not induce a voltage here on 3 and 6. We have found 3 and 6, 2 and 5 so far. We need to find out which one is 1 and which one is 4. So we're going to create an auto transformer by putting a jumper between 4 and 7. And we're going to see what the voltage is between this point right here, between 1 and the beginning of our auto transformer connection here at terminal number 8. Okay, so at that point we know that this voltage right here is going to be 10 volts induced. And if we look at our magnetic fields that are setting up, we've got these magnetic fields setting up like this. And when we take our voltmeter reading and we do from this terminal to this terminal, and we see the additive voltage of 128 volts, we can say with authority that the terminal that we are sitting on is terminal number 1. Right? Because this 118 is summing with this 10 volts to give us the 128 volts. Okay, if we change the jumper, so instead of going from 7 to 4, we're then going to go from 7 to what we believe is number 1 now. So there's our jumper. We're going to move our meter lead over and take a voltage reading between what we believe is 4 and 8 now. And at that point, you can, if you follow the circuit through, we're going to have the 118 volts. We're going with the arrow. We're going against the arrow. So we're going to subtract 10 volts. And that terminal right there that we're sitting on, with authority, we can now say is terminal number 4. So now we've been able to, once we've done everything, we should have been able to see our induced voltages here. On this case, if we put voltage here on 7 and 8, we'll see an induced voltage here on 2 and 5 and 1 and 4. And now doing the additive and subtractive buck boost test, we're now seeing with authority which one is terminal number 1 and which one is terminal number 4.
Okay, guys, so last one we have is we're going to put power to 7 and 8, right? So we got power coming in here. We got a jumper between 4 and 7. So there's a jumper between 4 and 7. And we're going to take a reading between 1 and 8. So let's put this bad boy here and this guy right here. And we should see, got a little bit of glare off the lights. There we go. We should see the additive voltage now. Let's turn this on. Beauty. Okay, so there's our additive voltage, right? We're expecting 128, but remember some of the induced voltages are a little bit lower. So there's our additive voltage. If I take that guy and move the jumper instead from 4 over to 1, then again, I'm going to backfeed that winding, and we should find the subtractive voltage. That lead is right in the way. Okay, so let's just put this guy right here. We're looking at the voltage between 4 and 8 now, and now we've got our subtractive voltage there. If we can just focus in there. Beautiful. That lead is fudging around with my my focus there. Beautiful. Okay, so now we've looked at all the different windings, and now with authority we can say which one is terminal 1 and which one is terminal 4 on the machine. There's a lot of work to try and figure out all the terminals of the motor. Let's turn that off before we smoke it. But yeah, that's a lot of work in order to determine all your windings on the motor. So hopefully all of the conductors are labeled for you out in the field. Now what we need to do is we need to take this guy, bring it into the shop where we've got 3-phase power, and then we'll be able to juice this guy up and get it running in both the low and the high voltage connections.